Welcome to the second video in the series on statistics for this course, and this one is called Measuring the Centre, and the question of course is, what does the centre mean anyway of a distribution? Okay, a set of data graphed like these in column graphs, and where would the centre of it be? Why would you want to do that anyway? Well, look around the screen. And people try to describe what's going on when they collect data. And you can look at the scores, which is very complicated if you've got lots of scores. Or you can draw a graph. But then they want to know, well, what's really going on? What's on the average, what I would expect from this data set? What's the middle? Over here, come up to the top left-hand side here. You can say, well, the middle, it's probably pretty symmetrical. It's right in the middle of that peak there. The modal value, the value that has occurred most often is called the mode. But it gets a little bit more tricky if you come over here, up on the top right-hand side here. Now, what would you say was the middle of this distribution? It's obviously skewed. We were talking about that in the last presentation. You don't have symmetry. Symmetry would be about there. You've got extra values to the right-hand side there on the positive side. And so what would you say was the middle of this distribution? You obviously get a few scores which are higher, but the middle is what? Somewhere in here, would you say? Can you see the difficulty now of giving people an idea of some middle point about which the scores are distributed? It's okay over here, again, go back here. It's okay if it's symmetrical. Everybody can sort of get the idea there. But if it's not symmetrical, then we've got some sort of issue in giving people a number of, all right, so you're buying a house in a suburb. What's the middle price? You know, is that add them all up and divide by how many there were, the mean? Or is there another way of indicating a middle price in the range that the houses were sold for in that area? Okay, so here we've got the idea of a positive, a negative side stretch there. So this is called positively skewed because we've skewed the distribution. It's not symmetrical anymore. This is negatively skewed because you've got extra on the left there on the negative side. Okay, and here we have bimodal. We've got two peaks here. So bi means two, bicycle, two wheels, bimodal. The distribution has two peaks, if you like, two modal values. Well, what do you do when you're trying to indicate to people where the centre of a distribution is, particularly for those that are not symmetrical down the bottom here? So that's what we're going to talk about, and we're going to say under what conditions would you use perhaps one measure of the centre, and under different conditions perhaps a different measure of spread. So let's go down now and have a look at the different measures of centre there. Okay, for discrete numerical data. So this comes from Hayes and Harris publications here, and it'd be good if you could get that book and have a look. The mode is the most frequently occurring value in the data set. Okay, the mode is the most frequently occurring. Okay, for discrete numerical data. So that's when you put it in a frequency table, for example, that's the score that's come up most often. We'll have a look at that. And for a continuous numerical data, we can't really talk about the mode because no two values would be exactly the same, would they, in continuous data? It would be very unusual for two people to have exactly the same height, for example. If you took it down to enough decimal places, probably you would be able to see that each person was a different height, not perfectly exactly the same. So we talk usually about a modal class. We group continuous data into groups and form a histogram, if you remember, where there's no gaps between the groups, and therefore we'll talk about a modal class for continuous data. So what that means is, here's one measure of the centre, and that is the one that occurs most often. Okay, so keep that in mind. You might have seen some of this before, but we'll just revise it now. And what about the mean? Now, the mean is something that people regularly use. What's your average test score in math, for example? You add them all up and divide by how many there were. Okay, so you could call the actual scores in your test x1 is the first score in the first test, x2, x3 up to xn. So you add them all up and divide by how many there were. Now this is very important, this notation here in maths, because it makes it a very neat statement of this. Instead of putting these dots in, you can say Greek capital sigma in maths means the sum of. So add them up. So that's a nice, neat way of saying going to add up all the x values. I'm going to call them I, xi, where I is 1 up to n. And then I'm going to divide by n. Technically, this should be written like this. I equals 1 to n of all the xi's, meaning x1, x2, x3 up to xn, divide by n. They've left out this part of the notation. But this is a Greek capital sigma, and we use it, sigma meaning sum, S for sum if you like, sum of all those scores. So if you're going on with maths at all, this is an important little symbol to a neat way of explaining what we're doing. So do you get the idea? Let's do one now. You got 15 out of 20 for a short test in maths. Then you got 18 out of 20. Then you got 16. And then you got 12, let's say. Hard one, that one. So what was your average mark? So here you could say this was 4 tests divided by 4. They're all out of 20. So your average mark out of 20 was 33, 49, 61. So this is 15.25. Okay, so if you added all those up, you would get 61, and dividing by 4, 15.25. So that would be your mean, and we do have a symbol for it. You put an X bar like that, X bar meaning the mean for your set of test scores out of 20. And you might not put 0.25, you might say, well, that's 15 to the nearest mark out of 20. All right, I guess you've done some of this before. If you haven't, join in now. It isn't hard. Let's go down and have a look at the median now. The median is the middle value when you put them all in order. So if you put all your scores in order, the middle value is your median. Okay, why might you want to do that rather than add up all the scores and divide by how many there are? We will have a look at that a bit later on. So if there are n data values listed in order from smallest to largest, the median is the m plus 1 on 2 position as the data value. Let's have a look. So if you've got 13 scores, add 1 to 13, that's 14, divided by 2 is 7. So the 7th score in that set of data put in order, remember we're putting them in order from smallest to largest, is the median. If n is 14, it gets a little bit tricky because 14 plus 1 is 15 over 2 is 7.5. So it's the average of the 7th and the 8th ordered data values. Let's just remember, what did we do up here? 15, 18, 16, 12. 15, 18, 16, 12 were your scores. So the first step in those test scores, put them in order. So it's 12, 15, 16, and 18. So now, because there are 4 scores, let's say n is 4, so n plus 1 is 5, m plus 1 on 2 is 2.5. So your median is halfway between your second and third score. Just remember this n here is the number of the scores, not the size of the score. So it's halfway between these two. So it is 15.5 would be your median score. Let's just bring that back again over here. That'd be your median score. So very close to the mean, wasn't it? 15 was your mean of 15.25. So is there any value in working out the median as well as the mean to measure centre? Oh, that's an interesting question. And I want you to think about that. Under what conditions would it be better to have one or the other? And we'll investigate that going down here. Okay, and this is the start of our investigation of those things. Here we are. For distributions that are symmetric about the centre, the mean and median will be equal, won't they? Because the median will be right in the centre, equal number of scores above it and below it. And the mean, because this is perfectly symmetrical, when you add all these scores up and all these scores up and divide by 2, it'll be perfectly balanced in the middle. Okay, so whether we add them up or whether we just position them, there's the same number above and below the median, and that median will also equal the mean because the size of the values above and below that point are equal. So they balance out. And here's another symmetric distribution. This is bimodal, two-mode values, so modal values here are exactly the same. And therefore, in the middle of that set of data, the middle would be what? The median, if this number of scores equaled this, and if the size of the scores was the same, when they added up, you would divide by the number, and it would be perfectly in the centre. So the mean and median would be the same. Now we're starting to get a clue down here with these two graphs as to why you might use one measure and not the other. Let's have a look at a positively skewed distribution. It means you've got some extras up here, haven't you? The distribution for symmetry would look like that somewhere. So we've got extra in the high range there, to the right. Now the mode is the peak, so there we got that. Okay. The median, because there's a few more scores up here, will be slightly moved to the right because of the number of scores up in this upper range. But look at the mean. Can you see why that would be moved further to the right? That would be more there, more to the right than the median. Now let's pause and maybe discuss this with your classmates. Why would the mean move further to the right? All right, let's come back and look at the answer. And the answer is because you actually add up here, the mean takes account of the size of the scores, not how many there are alone, but the size. So these are quite large, aren't they? Quite a bit larger than the ones further down the distribution. And so here, when you add those all up and divide by how many there are, you actually get an increase in the value of the mean, more so than what you would in the median. The median's only saying, well, you've got more up there. It doesn't take account of the size and boost that value by adding them as the mean does. And what about down here? Let's have a look. This is a negatively skewed distribution because that would be a symmetrical point somewhere. You've got extra down here, so you've skewed or upset the symmetry of the distribution. This is the group that have disturbed the symmetry or skewed the distribution. So the mode is still the highest value. The median, because you've got extra values here, then it's slightly to the left. But the mean will be further to the left because we're going to actually add on the size or add the scores up. And so it's the size of the scores is going to be important to the mean. And it's going to be moved more to the left. So now they won't quite be the same depending on how much skewness there is there. So what would be, in your mind, the better way of describing to people what's going on there? If you were to quote just one value for the centre, okay, you're going to say the centre of this distribution, give somebody an idea of the middle score, if you like, and when they're buying houses or something, in a region, what would be your indication here? Do you want to give them a measure that will be slightly pulled one way or the other because of the size of the scores, that's the mean, or would you rather give them the median? An interesting question, isn't it? So this question gets quite difficult if you haven't got a symmetrical distribution. All right, let's come down and have a look now. What we're going to do is to do a little bit of investigation. I'll leave the answer to that question till the end of the presentation, actually. So here's some, what is it, discrete data, yes? Because it's the number of family products returned to an electrical goods store each day over a 21-day period. We want to find the mean, the median, and the mode. Okay, so here we are. Let's have a look at that for a start. So the mean is add them all up and divide by how many there are, and we have on the average 5.38. Can you see here that means approximately? That implies approximately because we've rounded it off to 2 decimal places. Just note that you might say, well, that's silly. You can't have a mean of 5.38. You can't return 0.38 of electrical good. It's discrete data. Well, what we're saying there is on the average. So taken over 100 days, it would be approximately 100 times 5.38. That would be 538 items over 100 days. That's the idea. So although you can't have 5.38 with this discrete data, it is appropriate to say on the average in time, that's what's coming back. All right, so here, let's have a look now at the median. So you want here, there are 21 scores there. 21 plus 1 is 22. You want the 11th score. So you put them in order, and the 11th score is 5. Okay, so you've got a mean of 5.38 and a median of 5. Not much difference because this isn't a skewed distribution as such. It's fairly symmetrical. Okay, so what are we going to do with part 3 is the mode. We want the one that occurs most often, and so you look through your data set and you can see here there are 4 3s and there are 3 9s, but the 4 3s win because there's more 3s than any other number there. So 3 is the modal value. In part B, they've asked a part B question here. On the 22nd day, there were 9 faulty products returned. How does this affect the measures of the centre? So that's a big number on the 22nd day. It makes it more up here, isn't it? So let's have a look. So you'd had a total of 113, 9 more on the next day. Now divide by 22 days. So it's 5.55. That extra large value, the extra value on that day, which was on the larger end, has increased the mean. Can you see that? Because you've added on the size of its value. Let's have a look at the median. N is now 22, so this is 23 over 2, which is 11.5, was halfway between the 11th and the 12th value there, which is therefore the mean of those 2 middle scores, 5 plus 6 on 2, 5.5 faulty products. So here the new data has 2 modes now. It's got 4 3s and 4 9s. So can you see there that both of them have been affected by that large value put on the end? The mean's been affected a bit more because we added on the score rather than just put it there in as an extra store in order. Okay, can you see the mode is starting to get not so useful now because there were 2 modal values, 3 and 9. So if you're giving people an idea of the centre of this distribution, well, 3 and 9 doesn't indicate that very well, does it? Because you've got 2 modes on either end sort of the distribution. So this means we're going to be questioning the use of the mode. We're going to mainly focus in this course, as in statistics in general, on the median and the mean and seeing which of those, or whether we would use both of those, to measure the centre. Come down and have a go yourself, and we'll use the calculator here as well. So here we are, here are your problems. So let's go through. You might try some of these by hand, but it gets very tedious. I would suggest doing some by hand to get the hang of it, but let's have a look at the calculator. So here, the first calculator we've got here is the Casio. So an example of discrete data. What do? You go to stat mode on the calculator, as you do with the TI. We'll do that in a minute. Stat mode, and if you go to F6 and go to the page that's got graph on it, then you will have F2 calc and hit F1 there. So if you enter into list 1, first of all, we've got to do that, and then go to the next window to set it up as a calculation of a one variable statistic. So down there, of course, you go to the window that's got graph in the bottom left hand corner down there, hit calc on one there. But you must go to stat mode and enter the data into list 1 for a start. Okay, and then you just read down. So the mean is X bar up there, and the median is got to scroll down. So scroll down there, and the median is in there, and the mode is right at the bottom. Okay, so with the TI, it's the same thing. You go to the stat mode and enter into list 1, and then you've got to go to the from list 1 to one variable statistics, and then the same thing is applying there. So here, go to list 1, then one variable statistics, enter, and go to calculate and enter again, and a similar sort of situation there with the listing of all the things that you need. Okay, slightly different presentation there, but you've just got to go down and find the X bar, and so that's up the top there, X bar, median, and there's no mode function on the TI, so just notice that there is no mode function. And that's not a big disadvantage, because as I said to you, the mode is not a measure of spread that is all that useful, because quite often there's more than one mode. All right, so what I'll get you to do now is pause the presentation and have a go at these 4 problems, and down below I'll show you the work solutions as usual, not just the answers but the work solutions. So you can scroll ahead if you like at any time and check the answer as you do a question. In fact, I'd recommend that, because then you're not going to do a whole lot and get them all wrong. Check them as you go. Okay, so coming down now, there's question 1 to 4. Pause it and have a go. Let's go down now to question 5. Okay, pause it and have a go. Here's an example we should have a look at. If 6 people have a mean mass of that, find their total mass. Just remember the definition is the sum of all the things divided by the number is the mean. So set that definition up, and what you want to know is what they weigh in total. Maybe they're all going to get on the lift together, and you want to know the total weight. So the sum of the masses is multiply that by 6, and the total mass was that. So just remember the definition, because there are some little questions there which are variations on the mean. Okay, so that's question 5. Come down, let's do some with those variations. So coming down now, I'll put as many as I can on the screen. There's 6 and 7, and then 8 through 15. So have a go at a few of those. Probably not needed to do all of them, but try some by hand and some with the calculator. Make sure your technology is up to pace, because that's what we'll be mainly using in this course. All right, let's go down now and have a look at the answers to those questions, all 15 of them. So There's question 1. Pause it and check your work. Question 2. Let's see if we can get, we can get those on. 2, 3. Okay. And then 4. I think we get 4 and 5 on. And then coming down a little bit to there. Okay. I'll keep going now. Can we get them all there? I think we can. Okay, so have a look. A few explanations there to help you if you didn't get them correct. All right, let's move on now and have a look at what happens to these measures. As we did before, we can put data in, or discrete data here, in a frequency table. We've got a lot of measurements, and you've got 1, 3, 1 at 4, 3 at 5. So we did this to draw our column graphs, if you remember, for discrete data. They're discrete. Here there's no values between 3 and 4 or 4 and 5. So here, how would you find the modal value? Well, let's look down here, the one that occurs most. Let's look for, there it is, 15. So the modal value is 7. It's got the highest occurrence or the highest frequency. Okay, now we've got to add all these up. So this is a bit of a trap, because let's just rub this out here. Because if you started adding these up, they are the data scores, you'd be wrong, wouldn't you? Because you've got 1 of the 3s, 1 of the 4s, but 3 5s, 7 6s. So this product column is helpful. Just reminding you, 1 3 is 3, 1 4 is 4, but we've got 3 5s of 15. So look out, do not add up the data value. You've got to take account of the fact that some of them have occurred more than once. Okay, so that's what we're talking about over here. So the sum of all the data values over the total number, we actually have to multiply each value by how many times it occurred, the frequency, F. Okay, the frequency of it. Okay, so F, x2 times how many it occurred, x3 times how many times it occurred. Purely for the reason that if you had the score of 7 and it occurred 15 times, your overall total of all of those would be 105. You've got to add them all up. So in other words, look at this now. Now they've done a proper notation here. Sum from I equals 1 to k could have n over the total frequency. So you've got to add up how many were there all together. That's this column here, this one here, because the sum of all the scores was 40, the sum of all the times that each of them occurred. So don't forget to do that. So here we can abbreviate it without the i's. It's the sum of fx over the sum of the f's. So here 278 on 40 is approximately, see that squiggle sign there, approximately 6.95, because we have rounded the figure off. Okay, let's have a look now at the median. What will you do to get the median? Now there's a trick here as well. Here's your data set and here's the frequency. Now here's the trick here. To find the median, it's not a bad idea to construct a cumulative frequency column. In other words, you've got one score, which is 3 or less, and now you've got another score of 4. So there's 2 scores which are less than 4. So we're accumulating the frequency. And the accumulating is the verb. Cumulative, not accumulative, but cumulative is the adjective for the frequency. So by the end of the 5s, how many have we got? We've got 5 scores less than 5. By the end of the 6s, we've got 12 scores. Can you see what we're doing? We're doing here a table which indicates the number of scores up to and including that value. Okay, so what does this mean down here? 22. that's 27, are 7 or less. There are 27 scores 7 or less. So that's quite handy. I'll show you why. Because if we want the median, n plus 1 on 2 is 41 on 2, which is the 20.5th score, or halfway between the 20th and the 21st score. So coming down here, where are they? There's 12 scores up to there, and then the next, 15 scores are all 7s. Okay, so that means the 20th and 21st score are in this, up to this 27 here, are both 7s. There was 12 up to the end of 6, and the next 15 were 7s, so they are both 7s. So you don't really need to take the average of the two because they were both 7s. So the median is 7. So again, a fairly symmetrical distribution here, and the mean and the median are very close together. So be able to do it for discrete data in a table form there, frequency table form, because that's how we usually handle that. So hang on, what's this mean for our calculator? Well, we've got to be careful. Here it is, a number of aces in a sample of tennis players served by a sample of tennis players in their first sets of a tournament. So 4, 11, 16 are all the number of times the data set occurred. So we've got to times each score by the number of times that occurred. So we've got to add up this column, not this one, because we've got to multiply 4 lots of those, 11 lots of those. So here we are, we've got to add this up. Sum of fx over sum of f, 179 and 155, approximately 3.25 aces, okay, were served. So here the median, the trick there is to use this cumulative frequency column. 4 were 1s, and then the next 13 were 2s. The next 11 were 2, so this is 15 up to there. Up to 3, there's another 18, so that's 33. So this is increasing. This is the cumulative frequency, the number of scores up to the end of that value. Now, what do we need here? There are 55 data values. 55 plus 1 on 2. 56 on 2 is 28. Come down here. Where's the 28 score? 15 up to the end of that group, and 33 up to the end of that group. So the 28th score is actually in this group here. There it is. The 15th to the 33rd score, that includes the 28th, were all 3s. So the answer is 3 aces, the 28th value. So here, this is very handy to track that middle value by accumulating the numbers up to the end of that next entry. Okay, and looking for the mode now, you're just going to look down the frequency column. So I'll just scrub this out a bit here. So what's the highest frequency? There we have it, and that's a 3 also. So getting the idea, and of course look out, danger over here with the calculator, because you've got to put in the frequency somewhere. Otherwise the calculator will just think that's the data set if you put that in list 1 and forget to multiply by how many times they occurred. So you've got to go to stat mode again and put your data in to list 1, and also the important thing is to set it up and tell the calculator. So you go to F2 as we did before, F6 set it, and change one variable frequency to list 2. Here it is here. Usually the calculator is set up here as the Casio for a start, so that the frequency is just 1. Now we don't want that. We've got a frequency which varies, so we're going to put that in list 2. So see that? You've got to change that to list 2 here. It's usually 1 as default, and then you hit list and put 2. You've got to tell the calculator where the frequencies are going to be, and then you exit that F11 variable, and the same windows come up before. So, and you can read off the values. This is not that example, this is another example there. Okay, so here it's important to tell the calculator that you have a frequency. Tell it it's in list 2. This is a common mistake students make. And the same thing for the TI here. You've got to go to stat mode, go to 1, and 1 var stat second function 1 is going to give you list 1, second function list 2, and then you've got to enter those in there and scroll down to calculate and press enter. So it's the same thing, and here the same things, no modal value given on the TI. But the point here is you've got to tell the calculator, the graphics display calculator, that there is a frequency column in your data set, that each of them is not occurring once. So please keep that in mind when using the calculator. And a lot of what we'll be doing will be sent on the calculator. So all of this stuff over here is very important. You must be able to understand what's going on by hand over here, but we're going to use the calculator a lot. Okay, so come down now, and here's some for you to try. And this is 11B2 from Hayes Publications, so grab that book. So I'll pause it there, same as before, have a go, do a couple by hand, and then focus mainly on the calculator. 1 and 2. Here we have, let's go to 3, 4, and 5. So pause it and have a go. And then 6, 7, and 8. Okay, let's go down and look at the answers now. Here, fully worked solutions. So here we are, question 1 and 2. And then question, oh, there's the rest of question 2, sorry. Question 2. Question 3. And we can't get all of question 4 on question 3. It's down there. Question 4. And part of question 5. Don't forget the frequency. Question 5. Question 6. 6 and 7. And question 8. All right, well, you can see down the bottom of the screen here, we've got something coming up, and that is group data. With continuous data, of course, we group it to draw a histogram, and we divide all the continuous scores up into bands or groups, and here they've been done here. And we're doing a little bit of a shortcut here, 21 to 25, which means here the age is greater than or equal to 21, but less than 25. We don't need to put that in. That's an understanding here of that. And here, this age would maybe be taken to the nearest year, so it's really not continuous data as such, it's discrete, because we're taking it to the nearest year and getting discrete values, if you like. So here we've got a frequency, so let's set it up. This group has occurred 11 times, this group has occurred 14, etc. So how many did we measure? So first thing to do is to add up how many. There are 137. Oh, this is how we do it, is it? Look at that. You might say, well, I don't know how to do this one because I've lost the original ages. They've all been grouped there. There were 11 of them somewhere in here, but what was each individual? We don't know. So we have to now estimate the mean age. Okay, estimate, because we've lost the original data. So we're going to use the midpoint of each of the groups. Obviously, there's an error there. All those 11 people may not have had a mean or averaged out to the middle, 23. We could have had 10 who are 25 and 1 who is 21. So there is only an estimate. So there's an error here when we work with group data to find the mean and the median, particularly, and the mode. We've lost the original data. So we are estimating. So we'll do the same thing now. So the crucial thing is this column here. We're going to estimate each score in each of the groups as being at the midpoint value. So the midpoint is 21 plus 25 on 2, which is 23, and so on. So 26 plus 30 on 2 is 28, and they just go up by 5s because the length of the group is 5 here. 21 to 25 included is 5 scores. So as we go up there, and we're going to do that. So really here, we'll come over here, we're going to change this. We're going to go from 21 to 25 inclusive because the age has been rounded off to the nearest year. All right, so let's look at the product now because we're trying to find the mean. So it's this score, we're going to use that as a score times by that, how many times it occurred, divided by the total down here, the sum of all the scores that we measured, or the total frequencies, and we get approximately 37.7. Or because we're taking it to the nearest year, the data was to the nearest year, so the mean will take to the nearest year of 38 years. Okay, do you get it? Let's keep going now and have a look and see what we've got here. So here's our next set of data. Now this one is back to continuous data, so from 0 to 10 there, and we're going to have to find the middle point, and it's going to be the average of the endpoints. So we just go through there, but this time it's continuous data, it's lengths, and so you go up to 10, and if it's 10 or more, you go into the next group, as we were talking about before. Don't forget, each score occurs a certain number of times, so you must find the midpoint values and times them by the frequency. And when you're doing it with a calculator, the same thing. So pause the presentation and have a go. There's question 1, 2, and 3. And as you do a couple, or do one even, toggle forward in the video and check your answer, or check your answer from the back of the textbook. Okay, here we go. Let's go to question 4. Okay, so there's question 4. And come up to question 5. And let's have a look at some answers. Question 1 and 2. Well, we might be able to get it on here. No, we'll have to leave that. Question 3. Question 4. Question 5. Okay, now something I didn't mention there was the calculator, of course, is the same with the continuous data. You have to put in the midpoint, however, but you'll use the calculator in the same way. All right, well, how are you going with all that stuff? You might have to go back and just check it out again, but make sure you can do the calculation, particularly with a calculator, and just think about the mean, median, and mode, and think about the skewness there, and we'll talk again a bit later on about when to use the mean and the median, and it might be something to do with when skewness is present, mightn't it? Anyway, cheers for now. I'll catch you in the next presentation.